Alright, here we go with a Chapter 6 review, which is all about rational functions. Rational is a fancy word for fractions. So everything we're going to see here is going to be some sort of a fraction situation. So we start off nice and easy because this is stuff we've done numerous times throughout the year. Oh, I want to plug in a 2 where my x's are. So I'm finding f of 2. So that's 2 minus 10 over 13 times 2 minus 6. On top we get negative 8. On bottom, with 13 times 2 is 26. 26 minus 6 is 20. Negative 8 over 20 is what this becomes, but we're not done yet because we need to go ahead and simplify some more. So what can we divide into 8 and 20? What's the biggest number? That would be a 4. So you would divide both of them by 4 and get negative 2 over 5. That's your best answer because that's fully simplified. Number 2, we're going to plug in that negative 5. In general, we have to be more careful when we plug in negative numbers, but this particular problem, I don't think there would be an issue with you plugging it in, but I could be wrong, I guess. You might have issues. I mean about math. Negative 5 minus 9 is negative 14. 3 times negative 5 is negative 15. Negative 15 plus 8 is negative 7. We're not even really simplifying this, we're just dividing, and that gives us a positive 2. That's our best answer there. You could write 2 over 1, but that over 1 is just kind of being silly. You would write it as 2. Okay, the one on the bottom doesn't matter. On domain here. Now, domain can be a pretty complicated thing, but for our purposes, we've got fractions. Nothing in the top of our fraction is affecting the domain. So you can, if you want, okay, just mark it out so it doesn't throw you off. Remember that domain, the way we write it, is all real numbers. That's an abbreviation, all real numbers, except we say that x cannot be, and then that's what our job is right now. We have to set the bottom equal to 0 and solve. So we get x equals 6 by adding 6 to both sides. Okay, our job is to figure out what is that value or values that x can't equal, and in this particular case it's 6. Because if we put in a 6 here, then we get a 0 on the denominator, and that is very, very bad. On number 4, we've got an extra step we have to do, because to set this equal to 0 and solve, the only way we've talked about how to solve this is to factor. So we need to say, what do I multiply together to get the last number, 20, that when I add it together, I'll get the middle number, negative 9. And of course, we're all thinking negative 4 and negative 5. So you set that equal to 0, which means we basically have to split it up into 2 problems. What is x minus 4? Equals 0, and what is x minus 5 equals 0? Well, you're just going to get positive 4 and positive 5 by adding 4 over and adding 5 over. So our answer for 4, I'm going to write it above because I'm running out of room, is all real numbers except x cannot equal 4 or 5. So now we're going to move on to simplifying, multiplying, and dividing, which are all very similar. All of them involve, as the first-ish step, factoring. So like on top here, anytime we have 3 terms and it's y squared y and then a number, we are checking to see if we can split this into 2 parentheses, where, again, we're asking what multiplies to get the last number, that adds to get the middle number. So on top, what multiplies to get 36? Well, you've got quite a few options there, but to get 13, we need plus 4 and plus 9. On the bottom here, what multiplies to get 63? That adds to get 16. Well, we would do 7 and 9. And the reason we're factoring is because that's the only way we can cancel stuff out, is if we actually have things that are identical on the top and the bottom. So y plus 9 on top and y plus 9 on bottom cancel out, leaving us with y plus 4 over y plus 7. That is our answer. You cannot simplify that. you can't cancel the y's out. That you can't do that if there's plus signs on the top or the bottom or both, like in this case. On number 6, we need to factor anything we can. So we have 2y over here, because there's two terms, we're looking for if those have anything in common that we can take out. And so since we can divide both of them by 2, we can take a 2 out. So we write that out. And if we take a 2 out of both of these terms, we get 2y plus 1 left over times, okay, on top here, 14y plus 7, we take out a 7. And that gives us left over 2y plus 1, which is great. That means something will cancel out. And on bottom, we get 4. So, again, we're looking for things that are identical that we can cancel out. And so, in this one, we have 2y plus 1 that can cancel out. And then the other thing we have, you have to keep in mind here, 2 times y, those are being multiplied together. So if there's a 2 on top and a 2 on bottom, I'm allowed to cancel those out. If it was 2 plus y, we wouldn't be able to, but because it's 2 times y, that's okay. So that leaves us with y times 7 on top, which is 7y, and only 4 on bottom. You can't, if you check real quick, which is always good, 7 over 4 does not simplify, so this is our answer. The 2 on top we canceled. It could have canceled out with the 4 instead. It just would have been up to you which one you felt like doing. When we divide in number 7, the thing that changes is that we take the second fraction and we flip it so that instead of dividing, we are multiplying. That's the rule for division. So let's do some factoring and flip the second fraction at the same time. So on top of the first fraction, what multiplies to get 15, that adds to get 8. So that'd be 5 and 3. On the bottom, what multiplies to get 18, that adds to get 9. 3 and 6. Now we're going to multiply, and so because we're multiplying, that's what lets us flip this second fraction. And so let's do the bottom here, and we're putting it on top. So what multiplies to get 30, that adds to get 11. 5 and 6. And then on the bottom here, x squared plus 5x can be tricky. We have two terms, so we have to see what do they have in common. They have an x in common, so that's x plus 5 left over if we take out an x. Now it's the fun simplification game. Well, I think it's fun at least, that you have to see what cancels out. For example, I have an x plus 5 on top, an x plus 5 on the bottom. I have an x plus 3, an x plus 3. I have an x plus 6 and an x plus 6. The only thing I have left is an x plus 5 on top and an x on bottom, and you cannot cancel those x's out because there's a plus sign on top. So it protects the top from anything being canceled out. So that is 1 through 7. Alright, adding fractions, we need to check for common denominators on these first two. We have common denominators here. They both have a denominator of x minus 6, so we simply need to add our numerators together. So x squared minus 8x plus 12. Now none of those are like terms, so we can't combine anything. But notice it says simplify the result if possible, which means we should try to simplify. So on top, we need to factor if possible, and on this one it is. So what multiplies to get 12, that adds to get negative 8, that should be negative 6 and negative 2. And on bottom, we have x minus 6, so looky there, it does indeed simplify to just x minus 2. As our answer. So if you had stopped right up here, you wouldn't get all the points for that because you didn't actually find the simplest result. Now on 9 we're subtracting, and we have common denominators again. So 9, and think of subtraction like we're adding a negative. 9 plus a negative 5 is 4. On this one it doesn't really matter if you think about it like that, but over 5x squared. Check and see real quick. 4 over 5, does that simplify? No, it doesn't. There's not an x on top, so we can't cancel out an x, so that is our answer. On number 10, notice these directions. Find the least common denominator of the rational expression. It doesn't say add, subtract, multiply, divide. It just says find the common denominator. So we can completely ignore these numerators and just look at what our denominators are. So on bottom here, x squared plus 3x has two terms, so we have to see what's in common. There's an x in common, which lets us take out an x plus 3. X squared plus 4x plus 3 factors into two parentheses where we say what multiplies to get 3, that adds to get 4. Okay, so what we're looking for our least common denominator is a list of all of these factors, but we don't want to list anything twice unless it appears more than once in one fraction. Like if we had multiple x plus 3's in one of our denominator, then yeah, we would need more than one x plus 3. But because they're in different fractions, then we don't need to list it twice. So we have x, x plus 3, and x plus 1. But we only need a single x plus 3 without a squared or anything because they have this in common. There's not more than one needed. And you can check it by saying, okay, is there a way to make x times x plus 3 into x plus 1? Yeah, I multiply by x plus 1. Is there a way to make x plus 3 times x plus 1 be our common denominator? Yeah, I multiply by x. So this is our least common denominator. On number 11, we need to find a common denominator before we add. And so typically, if we can't factor our denominators like this, we have x and x minus 4. We just need to multiply those together, basically, and that's our least common denominator, which means that we need to multiply the first fraction by x minus 4, which is the second denominator. We need to multiply the second fraction by x, which is our first denominator, so that they both have a denominator of x times x minus 4. So that gives us 3 times x minus 4 over x times x minus 4 plus 5 times x over x times x minus 4. Okay, and writing it like this, now you can hopefully really believe me that we got common denominators. We need to distribute, so that's 3x minus 12 plus 5x over x times x minus 4. So 3x and 5x we can add together and get 8x minus 12 over x times x minus 4. And since it says simplify if possible, we do need to check and see if the top will factor. It will, because you can take a 4 out of both of these terms and we're left with 2x minus 3. So it factors, but it doesn't actually help us. So our answer is 8x minus 12 over x times x minus 4. Or you could put 4 times 2x minus 3 over x times x minus 4, and that would also be correct. 12, we need to factor here on the bottom, x squared minus 16. Now this can be kind of tricky, but remember that there's two terms, they have nothing in common, but we can take the square root of both of them, and there's a minus sign, which makes it factor to x plus 4, x minus 4. Okay, because we want something that multiplies together to get 16, but that when we add it together, we don't get a middle term. And so 4 plus a negative 4 is 0. The second fraction, before we actually go there, we're subtracting, we want to change this to plus a negative 5. Okay, that's going to make things easier later. So we need to factor this right here. We'll multiply to get 4 and add to get 5. 4 and 1. So we've got the parts of our denominators. So this denominator, x plus 4, x minus 4, is missing x plus 1. So that means we times the top and the bottom by x plus 1. The second fraction is missing x minus 4. So we times the top and the bottom by x minus 4. Now this means that on top here we're going to have to distribute, okay, for our numerators. So x times x is x squared, x times 1 is x, and then negative 5 times x is negative 5x. Negative 5 times negative 4 is plus 20. That's all over our common denominator, which it doesn't matter which order you write these in, just make sure you write it without like accidentally screwing up. And like terms on top need to be added together. See if you can factor on top. Is there anything that multiplies to get 20 that adds to get negative 4? The answer is no, so this is our answer. Complex fractions. So what we're trying to do is get a fraction on top of here and a fraction on bottom so that we're dividing two fractions, which we did earlier. Like, it's where we flipped the second fraction so that we can multiply. So first off, make this 4 be 4 over 1. Then we need a common denominator for 1 and x. So that would be 1x, or just x, so that the first fraction needs to be multiplied by x. That means that on top here I'm going to have 4x, and then plus this other fraction didn't need anything because it already had a denominator of x. So this is our top fraction. Now on bottom we have 4 and 8, and we need a common denominator. Well, if we think about it, hopefully we realize you can multiply 4 by 2 and get 8, but if we do it to the bottom, we also need to do it to the top. So that gives us 2x plus 1 over 8. The top divided by the bottom will give us our answer. So 4x plus 2 over x times, we flip, so that's 8 over 2x plus 1. Now check to see if anything factors, because 4x plus 2 actually you can take a 2 out of, which gives you 2x plus 1. Since I factored that, I'm not looking at 4x plus 2 anymore. I changed it to this, and something cancels. Look at that. 2x plus 1, 2x plus 1. So on top we have 2 times 8, which is 16. On bottom we have x. So our answer is 16 over x. 14. Let's make these ones be over 1. In each case, we need a denominator of a, so we times by a on the second fraction. So 3 plus 1a is on the very top, so that's just 3 plus a, over our common denominator of a, over 3 minus 1a, which is 3 minus a, over our common denominator of a. Now we're ready to flip the bottom fraction, 3 plus a over a times a over 3 minus a. It's very important that you remember you're flipping the second fraction, not the first fraction, because otherwise you get almost the right answer in this case, but it's not the right answer. So 3 plus a over 3 minus a is our best answer. You can't cancel anything out because it's not the exact same, and we have that plus sign on top and the minus sign on bottom, which keeps us from being able to cancel. 15. Remember that each thing on top gets divided by 5x to the 6. 35 divided by 5 is 7. X to the 7th over x to the 6th is x to the 1st, because you subtract the exponents. So that gives you x. 25 divided by 5 is 5. X to the 6 over x to the 6 cancels out, so that you don't have an x term here. And then 30 divided by 5 is 6. But if we subtract the exponents for these x's, we get 1. But there's more x's on the bottom, so we put the x on the bottom. Alright, long division. Set it up. Okay, and here's what we're doing. We're going to figure out, what do I multiply 3x by, and we're always going to talk about this one. What do we multiply 3x by to get 15x cubed? Well, 3 times 5 will give us 15, and x times x squared gives us x cubed. And I personally like to write it over here to line up my x squareds. Then we multiply both of these by 5x squared and change the sign. So this is 15x cubed, but we change it so that we're subtracting. 5 times 5x squared is 25x squared, but we're subtracting, so it changes to instead of a plus, it's a minus. Cancels out the first thing. 37x squared minus 25x squared is 12x squared. So we drop down the 11x. Now it's like we start over, because we say 3x times what gives us 12x squared? 3 times 4 and x times x. So that's 12x squared, but we're subtracting. 5 times 4x is 20x, but we're subtracting. So this is negative 9x minus 2. So now we say, what do I multiply 3x by to get negative 9x? Well, I need a negative, and I need a 3. I don't need an x because it has the right number of x's. Now 3x times negative 3 is negative 9x, but we are subtracting, so it changes the sign. If you subtract a negative, remember it makes it a positive. 5 times negative 3 is negative 15, but we're subtracting, which makes it positive 15. So this is 13, which is our remainder, so we write plus 13 over what we're dividing by. Now, one thing to notice, because the thing that tends to trip us up is this whole changing the signs thing. If these have the same sign, they're both positive, then each time we write our thing down here, they should have the same signs. So because this first one was a negative, because we needed to cancel out the 15x cubes, this should be a negative as well. This was a negative, so this was a negative. This one ended up being a positive, and this one ended up being a positive. They should match if they match up here. If they don't match up here, then you'll always have opposite signs. So that's just hopefully something that helps you and doesn't actually make it worse. Alright, synthetic division is awesome. The first thing you do when you see synthetic division is you change the sign here from a plus 5 to a minus 5. Put it in a box. Put just the numbers from up here, making sure that nothing is skipped. Like we have x cubed, we have x squared, we have x, and then we have a number, so they didn't skip anything. Okay, you take the first number and drop it down, so that's negative 6. That's always the first step that we do, is we always drop that first thing down. Then it's a pattern. We do multiplication. Negative 5 times negative 6 is 30. Addition, negative 36 plus 30 is negative 6. Multiplication, negative 5 times negative 6 is 30. Negative 27 plus 30 is 3. Negative 5 times 3 is negative 15. 15 plus negative 15 is 0. And then to write it as our answer, we always start one to the right of what we began with, because if we're dividing, then because we're dividing an x cubed by an x, that's going to give us an x squared first. So this is negative 6x squared, and then you count down your powers. So minus 6x to the first, which is just x, plus 3 without an x, and then if we had a remainder, that would go next, but since we don't write the 0. That's our answer. Now 18 is tricky, because you have to remember that they've skipped a whole bunch of stuff here. They skipped x cubed, they skipped x squared, they skipped x. They didn't skip the number though, so that at least that's something. So we change this sign so that it's a positive 2. And then we write our coefficients, but we have these zeros here as placeholders because they didn't put everything between x to the 4th and 16. If you don't put those zeros there, you will get it wrong. So drop the 1, multiply, add, multiply, add, multiply, add, multiply, add. See, it's a pattern, in case you didn't notice already. We always start 1 to the right, so since we began with x to the fourth, we need to start with x to the third here. So this is 1x to the third, which is just x cubed. Count down your power, so plus 2x, next comes squared, and then comes x to the first, which is just x, and then comes our number, and then we're left with our remainder, which we write as 32 over what we were dividing by, which is x minus 2. Now, 19 and 20. To solve a rational equation, we are trying to figure out what to multiply by so that our denominators cancel out. So, one way to do it is basically take your denominators and just stick them up here that we're going to multiply. Like we have an a, we're going to multiply by a. We have a 4, we're going to multiply by 4. We have another a, well, we've already taken care of it. We don't need to multiply by an a again. So we're going to multiply everything in this fraction by 4a. To write it out the long way so that you can see what exactly is going on is we are multiplying every single thing in the equation by 4a over 1. So we can look and see that things will cancel out, like this a and this a, this 4 and this 4, this a and this a, and it's possible that you could have distributed and canceled at the same time. Just realize that this needs to be in parentheses. We have, for this first term, we have left 4 times 5 minus a. Here we have 3 times a, and then 7 times 4, which is 28. We just need to solve this. So, like, distribute. You can add like terms, so this is negative a. We can also subtract 20 over to this side, which gives us 8. So negative a equals 8, which means positive a equals negative 8. You do have to check and see. If I put a negative 8 in either denominator, in any of the denominators up here, does it cause a problem? The only way it could cause a problem is if it makes a denominator 0. Well, this didn't make a denominator 0. It made it negative 8, which is fine. Denominator can be negative 8. So that is our answer. Now on 20, it does kind of matter that we check and make sure that this factors into what our other denominators are, and it does, because 42 is 6 times 7 and 13 is 6 plus 7. Because what do we need to multiply to get rid of our fractions? Well, we need to multiply by x plus 6 times x plus 7. So, on this first fraction, 1 over x plus 7, the x plus 7 cancels out with the x plus 7, leaving us with 1 times x plus 6. Plus. Okay, here the x plus 6 cancels out with the x plus 6, leaving us with 5 times x plus 7. Here, both of these cancel with both of these, leaving us with negative 1. So you can do it that way without having to rewrite. It's up to you. You have to know if you're able to skip that step or not, and it be okay. If you can't skip it, then don't. If we distribute the 1, we get x plus 6. If we distribute the 5, we get 5x plus 35. That equals negative 1. We've got like terms. So 6x plus 41 equals negative 1. Subtract 41. 6x equals negative 42. Divide by 6. X equals negative 7. So now we need to think about what we have up here to check to see if this is really an answer, because if we plug in a negative 7 where x is, like here on this first fraction, negative 7 plus 7 gives us 0 on the bottom, and we're not allowed to have a 0 on the bottom, which means this is not really an answer. This is no solution. Okay, if you get something and when you plug it back in, it gives you a 0 in your denominator, and I could plug it into all of these, you would plug it in until you find a problem or until you've plugged it into all of them, whichever one. If it gives you a 0 on the bottom, that makes it no solution.